Hey, DDCHJ here, and welcome to RLBot Start to Finish. In this episode, we'll be taking a look at some of the other routines provided by Gaussing Utils and making one of our own. Hey everyone, welcome back to the series. In the last episode we looked at jump shots and the aerial routines. In this episode we're going to be looking at a couple more as well as making a Wavedash routine. The first routine we're going to take a look at today is called flip, and it does a flip/dodge, whatever you want to call it, in a given direction. The direction, as with most things, is given in local coordinates, and there's also additional option whether or not we want to cancel the flip halfway through, so we can do something like half flips. To demonstrate it, I think for fun, I'm going to make it endlessly dodge towards our opponent. So let's see how we would do that. First thing, of course, when working with routines is to make sure that the stack is empty before we create a new one. So I already have the if length agent.stack is less than 1. I already have that there. The next thing we need to do is figure out the direction our opponent is from us. So let's go ahead and make a relative target. It might be worth noting that I'm calling agent.fo0.location. If you don't have an opponent, this code would crash. So it might be a good idea to test to see if you actually have an opponent before running something like this. Once we have a relative target, all we need to do is just convert it into a local target. And then we can push a flip routine. Cool, and that should work. Let's go try it out in the game. Okay, we've jumped into a game and let's see what happens. Yep, this is pretty much what I expected. Okay, well, that's that. Let's go take a look at another routine. The next one I think we'll look at is called short shot, and it's very similar to jump shot as I said in the last episode. All it takes though is a target that we want to hit the ball towards, and it'll try and hit the ball towards that point. Compared to a flip, the setup is going to be a lot easier. We're just going to do agent.push and short shot. And push the location of our opponent's goal. That's pretty simple. Let's go see how it works. You can see they both took very wide swinging kickoffs in hopes of scoring a goal here. Oh, nice shot. Watch blue specifically. Yep, this is pretty much short shot. It just kind of runs around, goes after the ball. It will go up on the walls. That is one nice thing about it. One thing jump shot won't do is go for wall hits, but the short shot will go for wall hits because it goes for anything. It's also pretty good at clears. Honestly, a bot that just uses short shot wouldn't be a bad bot, except for the fact that it gets confused when the ball is too high. Oh, what a shot. Maybe I should just use short shot only. I don't usually use it. I might have to convert. Okay, of course that works pretty well and it's simple enough to use. Now let's go check out something else. Okay, the last built-in routine that we're going to be looking at is called go-to boost. Now there is also a go-to routine, but it's not really useful. I don't recommend ever using it. This one is useful because it will keep track of the boost as you're driving towards it and pop the routine if the boost is picked up or if you reach full boost before you can reach the targeted boost. So let's go see how to implement it. Okay, the first thing we're going to want to do is identify the boost pad we want to pick up. So let's go ahead and make a list of all the large boost pads on the map. Okay, so what I've done is I've made something called large boost, which is a list that has every single boost that is both large and active. Next, what we'll do is try and figure out which one is closest. Okay, so this took a little bit of work to get set up, and there's probably a bug in it that I haven't figured out yet, but what we're going to do is loop through this list of the large boost that we found, check the distance of it, see if the distance is less than the closest distance that we've already found, and if it is closer, then it'll be our new closest. At the very end, we're just going to push a go to boost routine and give it the closest boost we found. It's worth noting that if we can't find a large boost that's active, this list will be empty and this code will crash, so I don't recommend copying it word for word if you intend on using something like this. Anyways, let's go see how it works. Okay, I've got everything set up properly, and let's see what happens. Immediately off of kickoff, our bots go for boost, and then go for mode boost, and then go for more. And then they run out of boosts because they're all empty, and wait until some respawn. Wow, this is very symmetrical. That's pretty cool. Yeah, right now, when they go up on the ceiling like that, they're crashing because there's no boost available on the map. Okay, there's one more thing I'd like to show you guys with the GoToBoost tool that you may find useful. When we create a GoToBoost routine and push it to the stack, we can provide it with a boost, but we can also provide it with a target. So if I give it agent.ball.location, what it means is that it will travel towards the closest boost, but try to realign itself so that it's facing towards the target by the time it reaches the boost. It won't be perfect, but let's see what that does. You see, it's trying to face the ball, but it's mostly just going for the boost right now. Okay, because we're 7 minutes into this video already, I'm not going to go line by line through the Wavedash routine, making it. Instead, I've already written it up, and I'm just going to walk you through how it works and how I made it. So, of course, we make a class Wavedash, and we have an initialization function which sets a variable called step equal to 0. This variable will be used to keep track of the number of frames that have passed since the routine started running. Next, we have the required run function that all routines need to have, except the agent. And then we kind of have to break things down into steps. Now, how does a Wavedash work? Well, we want to jump up in the air, tip our car back a little bit so that we land on our back wheels first, and then dodge once we get close to the ground again. So the first thing is figure out where do we need to point the nose of the car in order to make sure our back wheels land first. That is satisfied by this if-else statement. Now there's two different cases here, of course. One is if we are moving quickly, i.e. our velocity is greater than 100, which I guess isn't that quick, but yeah, so if our velocity is greater than 100, we're going to be pointing in the direction of our velocity at a point that is 100 units away and 50 units up. Now, to be consistent, if our velocity is less than 100, we're just going to point towards our car's forward-facing direction, 100 units forward and 50 units up. Once we have that target, all we do is cast it into local coordinates and then call default PD on it, so our car will always try and point towards it. That takes care of pointing up so that our back wheels land on the ground first, but now we have to handle the jumping and dodging part. So the first thing we do is increment our step to signify that a frame is passing, and then we check to see how many frames have passed. If we're less than 5, then we're going to be holding the jump button. This will get us up off the ground. Now, we have to be able to dodge after this, which means we have to let go of the jump button at some point. So for the next 3 frames, we're actually going to be letting go of that button. That way we can press it again in order to do our dodge. If we've already held our jump button and then let it go, we are basically ready to do the Wavedash, so we come down to these last 2 conditions. The first one is whether or not we are close to the ground. It looks at our current location and our current velocity times 0.2 seconds into the future to see if our z coordinate is going to be less than 5. If it is, then self.jump becomes true, we pitch down, and we stop our yaw roll. That'll just cause us to dodge forward. Then we pop the routine, so all of this only happens for 1 frame. Now I do have one more thing down here, which is kind of like if something went wrong during our jump, and that's if we're not airborne. So if we did our jump and let go of the jump button and we're still on the ground, we're going to pop the routine off the stack because we don't want it to be sticking around not working. So while it looks pretty complicated at first, we can see how it gets broken down into individual steps, and let's go check out how well this code actually works. Okay, here we are in a match. Let's see how this works. Quite well, actually. I think I'm going to call the video here. Thank you for watching and hope to see you in the next one.